Hey everyone, welcome back to the channel. I hope you guys are doing extremely well. So this is another lecture from the Strivers A to Z DSA course. Just in case you're for the first time here, this is the world's most in-depth course when you talk about DS algo. Why do I say that? 455? Yes, this course has 455 modules. By the end of the course, you have solved more than 400 plus problems when it comes to DS algo. You can go over the entire internet. You can buy any of the paid courses. None of them will be teaching you DS algo in such steps. Something that I can give you as assurances. Once you cover up the entire course, you will be able to clear any of the DS algorithms in any of the companies in any part of the world. So till now, I have covered up till this particular problem. Now in this video, I'll be solving the problem count number of subarrays with a given XOR k. But please make sure that before attempting this particular problem, you should go back and watch this problem, which is counting the number of subarrays with some k. Because the concept that I have used in this particular problem will be reused in this problem as well. So I'll be leaving the video link in the description. In case you haven't seen it, please go back and watch it and then you can resume this particular video. So what does the problem state? It states that you have to count the number of subarrays with a given XOR as k. Now what is the definition of subarray? Any contiguous, very important word, any contiguous part of the array. So something like 2 to 6 is a subarray. Something like 2 and 4 is not a subarray where you pick this 2 and this 4. Why? Because it is not a contiguous part. So a subarray is a contiguous part of the array. Something like 6 is also a subarray. Something like the entire array is also a subarray because it is a contiguous part of the array. So that is what you mean by subarray. Now you will be given a k. Over here, you're given this particular array and you're given the value of k as 6. Can you tell me how many subarrays are there who will give you the XOR as 6? So I can say there are exactly 4. Why? This one, if you take 4 and 2 and you do a XOR of 4 and 2, the value that you'll get is 6. If you do not know about the XOR operator, you can Google about it. You will get to know what does XOR operator does. Again, if you take this particular one, it's a single element. So any single element, you do not need to do XOR with anything else. So the XOR will be 6. For this, 2 XOR 2, XOR 6. And as you know, XOR of similar elements means 0. So XOR is 6. For this, 4 and 4 will cut off because they are similar. 2 and 2 will cut off because they are similar. So it will be basically 0 and you'll be left off with 6. So you're getting this particular XOR. So how many subarrays are there? 1, 2, 3, 4. And that is what you have to return. You have to return me the count of the subarrays with the given XOR as k. That is what the problem states. So this problem comes up in an interview. What is the first solution that you'll give to the interviewer? That is definitely the brute force. And if you're talking about subarrays, what is the extreme range solution that comes to your mind? Generate all the subarrays. And how can you generate all the subarrays? It's very simple. You know one thing. The first subarray is this. The second subarray is this. The third subarray is this. The fourth subarray is this. The fifth one is this. And then this one is the 6th, 7th, 8th, 9th. Then this. Something we know for sure is you stand at 4 and you keep on expanding, right? So what I can say is maybe I can start a loop from 0 and I can go until n. Again, I'm not going into deep because I've already taught you how to generate subarrays. So I can probably stand here and now I can say, okay, 4 is the first subarray. So I can just start with 4. Then I can take 4, 2. So something I can say is, okay, maybe there will be another loop j which will start from I and it will go on till n. So if I have to look at the values, at first I will be 0, which is this, and j will be at this portion. So this is the entire subarray. Then what happens to j? I stays here, j moves here because j will move with j++. So this is the subarray. Then what happens to j? J will move here and I will still be here. So this is the subarray. Next, j will move here and I will stay here. So this will be the subarray. Next, j will move here and I will stay here. So this is the subarray. After j has completed, what will happen to I? I will move to 1 and the same I will be here. What about j? J will start from here. So this will be the subarray. Next, j will move here. I will be here. So this will be the subarray. And similarly, you can go on. So can I say this? that the subarray is from I to j. Can I say this? Because if I is standing here and j is standing here, I definitely know this is the subarray, right? So probably we can keep the XOR value as 0, and I can say XOR equal to XOR of array of k. So what this will do is, this will iterate through the entire subarray and give me the XOR stored in the XOR variable. After this loop is done, I can say the XOR of that subarray. If that is equivalent to what we are looking for, we can do a counter plus plus. Quite simple, and this is how the code will look like. So if I have to analyze the time complexity, can I say it's near about big O of n cube? Near about, because we are running 3 loops. First to generate the subarray, next to go through the subarray and compute the XOR. So the time complexity is near about big O of n cube. What about the space? We are not using any space. So big O of 1 is the space complexity. Obviously the interviewer will not be happy with n cube and he'll ask you to optimize it. This is when we will move to the better solution. What about the better solution? Can we observe something? Do we actually need the third array? We do not need it. Why? I'll tell you. So imagine I just end up removing this. I'm removing this. Let us have some observation. So imagine I was here and j was here. I know the first subarray will just have 4. So the XOR will be 4. Next, j moves here. So the next subarray is having 4 too. One more element at it. What will be the XOR? 4 XOR 2. Next, j moves here. So another 2 will be added to the subarray. So eventually as j is moving, the next subarray is including one more element. So can I say, if I can keep a XOR variable, next time 2 gets added, next time another 2 gets added, next time 4 XOR 2 XOR 2 XOR 6 will get added, next time there is already this, 4 will get added because of this one. Eventually I can keep on adding. This is what I'll do. I've already done this previously. XOR can be 0, and every time I move forward, I just add up the new element, and whatever XOR I'm getting, if that is equivalent to k, I keep a count. So what I've done is, I boiled down the time complexity to big O of n square by just using 2 loops. Again, I've explained this in depth in the previous video. That is why I'm not going in depth, because I know you know how to generate subarrays, how to optimize it to n square. So I'm not going into the depth. Okay. So this will be the better one. Obviously, the interviewer will not be happy with n square and he'll ask you to optimize it. And this is when you'll move to the most optimal solution. So what will be the most optimal solution? Let us have some observations. Now, can I say one thing for sure? Let's take this subarray. I know this subarray will be giving me a XOR of 6. I know that for sure. If I have to ask you, where is the subarray starting from? It is starting from here. Where is it ending? It is ending here. So I know one thing for sure. Every subarray will have an ending point for sure. Like this one has an ending point as this. 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 Every subarray has an ending point, because it will. And it also has a starting point. So I will be focusing on the ending point. Let's see how I will do it. So if I have to just manually write down this particular array, let me write down 4, 2, 2, 6, 4. And I'm asking you till this portion, which is if I take up all the elements, and I say the XOR till 6, very important, till 6 is XR. Imagine the XOR of all the elements till 6 is XR. Okay. Now I am asking you, imagine these many elements have a XOR as K. Just imagine, hypothetical scenario. These many elements have a XOR as K. Can I say then this will, again, let's hypothetically take it as X. So what I'm saying is, the first element has a XOR as X. From here to here, it has a XOR of K. And the entire thing has a XOR of XR. Can I write something like this? X XOR K will be XR. Again, makes sense because this element and all the three elements, if you XOR, that is equivalent to the XOR of all elements. Now, I will say, take XOR of K on both the sides. Do a XOR of K on both the sides. So, in XOR, if you XOR same elements, it will always be 0. If you XOR same elements, it will always be 0. So, K and K's XOR will be 0. So, you'll be left off with X. X will be nothing but XR XOR K. X will be nothing but XR XOR K. And remember this formula. X is nothing but XR, where XR is the XOR of the first elements till this index, till any particular index, where K is the XOR that you're looking for. Now, just imagine. Forget about this. Forget about everything. And just have this derivation. So, if I ask you till here, it's like 4 XOR 2, XOR 2, XOR 6. What will be the total XOR? It's like 2 and 2 will cut off. It's like a 4 XOR 6. So if I have to do a 4 XOR 6, it's nothing but 0, 1, 0. The value is 2. So till here, the value is 2. What am I looking for? I'm looking for, is there any subarray? I repeat, is there any subarray that is ending at 6 and is having a XOR of 6? Is there any subarray that is ending at 6 and having a XOR of 6? I'll write it so that it sticks to your head. Is there a subarray ending at 6 and having a XOR of K? Now you'll be like, maybe not. So I don't know anything. I just know the XOR of these elements, which is 2. So what I will say is, that is only possible if I have a X whose value is XR XOR K. You remember when we took this, then only it's possible. There can only be a subarray who will give me a K only if there is an X. What is X? Some elements from the start. Which will give me X. So over here, XR will be 2. What will be K? K is 6. I am saying 2 XOR 6. What is the value of 2 XOR 6? That is 4. Because 1, 1, 0 is 6. 2 is this. So if we do a XOR, it will be 0, 0, 1, which is 4. So 4. Do we have someone from the start which is giving me 4? I say yes. From the start we have a 4. We have someone who is giving me a 4 XOR. Thereby, I can surely say there exists some elements which will give me the K. That's it. That is the funda. What we will try to do is, we will try to move and we'll keep a track of the pre-XOR, like the entire XOR of all the elements. And then we will see, is it possible to end over here by taking some K? And if I can figure out from the front, if I can figure out an element, so basically, I will move, taking an XR, and then I'll say, is this the end? Is this the end point? So maybe someone will be K. For someone to be K, from the front, someone has to be X. And I'll just find out, is someone X? And if someone is X, that's it. My job is done. And how many X's would we have to look for as well? How many X are there is also I have to look for. Got it? So I'll tell you as we move forward. Perfect. I hope you have got the intuition. The intuition is pretty straightforward. We are kind of looking from the backward direction. If anyone is there, I can suddenly erase it. And now we will start doing it. So what do we need? Let's go back. I will be carrying the XOR of all the elements. And I'll be looking for, does there exist any subarray with K XOR? For that to happen, I will look from the front, is there anyone with X? So it's like from the front means I have to keep a track of the XOR of the front elements. To keep a track of the XOR of the front elements. That is what I will do. Let's quickly start. So in order to keep a track, which data structure? Yes, hash map. Hash map is what you require. So we'll take a hash map. We will say front XOR or something like this, which will be my key. Front XOR X. I'll say how many times? How many times? And initially, we don't have anything. So maybe 0, 1 will be a good element because no one means 0, 1. I don't have anyone. 0, 1. Let's start. XR is 0. First element, 4. First element, 4. So XOR, 0 XOR 4 is 4. So what I am saying is, as of now, XR is 4. So this entire thing is 4. I'm looking for K. Is there any K? So I'll be like 4 XOR 6. What's the value? 2. The value is 2. Did we get a 2 previously? No. We did not get a 2 previously. That's not in the hash map. So nothing. Keep a count which will keep a track of the count as well. Let's move. Before moving, please make sure you remember front XOR 4 appeared once and then move. 2. 4 XOR 2 will be nothing but 6. 4 XOR 2 will be nothing but 6. Now what you are saying is, from the front it is 6. So what are you looking for? You're looking for a K. You're looking for a K equal to 6. And you're looking for a X then. What will be X? If you remember the formula, X was XR XOR K. XR is 6. So K is 6. X is 0. So you're looking for, did you get a front X as 0? Anyone with 0. And you know, while you started, you had a 0. So that means this entire thing is a subarray, which is your answer. So thereby you say count is 1. Next, front XOR 6. Front XOR because these two elements are giving you 6. Store it with 1 occurrence and move. You move, so it's a XOR of 2. It's a XOR of 2. 6 XOR 2 will be 4. So go ahead and write 4. Written. Next, let me erase this and show you what will happen. So you are saying, I have 4. I'm looking for a K equal to 6. So how much X am I looking for? How much X did something appear before? How much is it? 4 XOR 6. What is 4 XOR 6? That is 2. You can just do it. It's very simple. 1 0 0 1 1 0 0 1 0. So 2. Do we have a 2? You look. No. There is no front as 2. So this 6 is not possible. So I cannot get. Thereby, I'll just erase it. I'll keep a track of this 4. So when I keep a track of this 4, it will be like 2. Remember this. This will increase. I have 2 times. Next, let's move. We move to 6. What will be 4 XOR 6? That will be 2. Very good. This time, what am I looking for? I am saying I'm having XR as 2. I'm looking for a K equal to 6. So I'll be looking for front X. What will be the value of front X? It will be XR2 and XOR K. Because that was the formula. If you remember that was the formula. So 2 XOR 6. 2 XOR 6 is how much? It is 4. It is exactly 4. So you will go back into the hash map. Hash map will say there are 2 elements who have a front XOR of 4. Again, eminent. Because even if you take this entire subarray will give you a XOR as 6. Okay. Even if you take this, which is your front X equal to 4, and even if you take this will give you this. So there can be 2x, there can be 2x. So once x can be just this one, and the other time x can be a significantly large number of elements, which is the 3 elements. I have to again write it just for explanation. 4, 2, 2, 6. So what happened? You said, okay, this is giving me a K6 and this is my X equal to 4. And similarly, you can also say, this is also giving me X equal to 4 and this is giving me K equal to 6. So there can be 2 subarrays ending at 6. there can be two subarrays ending at 6. One is this, while the other one is this. That is why in the hash map I was storing the count. How many x were there? It told me there were 2x. One is this and the other is this. Thereby this 2 will get added and the count will become 3. Quickly I'll erase this. Next I'll move. Before moving, I have a 2. I'll insert it with the count 1 and then I'll move to 4. 2s or 4. What is the value? 6. Very good. 6. So if you're looking for 6, entire thing is 6. Sorry, XR is 6. You're looking for a k equal to 6. What will be x? X will be 0 because 6 or 6 is what you're looking for. 0. Do we have a 0? Yes. What does that signify? If you end up taking it, the entire thing, that will make sense. That is why I was storing the 0. So eventually x is 0, the count increases and the count ends up being 4. Perfect. After that, you can again go ahead and put the 6, the count will increase and the iteration is over. And overall, the count will be storing your total number of subarrays, which in this case is 4, and that will be your answer. Got it? So time to code it up. So you can find the problem link in the description. Please make sure that you try out the problem from the link in the description itself. We are given an array, we are given a k. First thing I'll do is, I'll take an XR and I'll say 0. And I'll take a map and this is what I'll do. So I know initially I can keep XR plus plus. So if it is not in the map, it will automatically take it as 0 and it will make sure that 0, 1 is inserted in the map. So while we start, let's quickly iterate on the vector of the list. And every time we go, we have an element. So we say XR XOR of that element and that will be A. Now what do we have? We have XR. We are looking for K. So we will look for, did we have any previous occurrence of X, which is XR XOR K. You remove the formula and you have to look in the map. How many times does this X appear? And that will be added to your count. If it appears 0 times, we cannot have it because we need X to be appearing. So count plus MPP X. So if it doesn't appear in the map, it will automatically be 0. And that is how map works. And if it appears, it just takes how many times. If you remember, this 4 was 2 times. So if it appears, it will take 2. And we'll add it up to the count. At the end of the day, you can go ahead and return count. 4-line code. For such a wonderful concept, the lines of code is hardly 4. Okay, I did a mistake. That's because we have to also make sure that before going, we put it into the map. So put it into the map and now we will be running this off. So if you see, this will be running fine and now I will go ahead and submit this. So what is the time complexity? Big O of n, and we're using a map data structure. You can say login. If you use unordered map, it will be big O of 1 in the best case, but in the worst case, it might be something else. So you can explain that to the interviewer. So n can be the time complexity or n log n, depending on the time that your map ends up taking. So that will be the time complexity. What about the space complexity? Big O of n. Why? Because you're using a map data structure and every time you're storing something in the map. So if this XR that you're storing happens to be unique every time, so you'll end up storing n different elements. So the time complexity can be big O of n or n log n depending on the map's time complexity, and the space complexity will be big O of n at the worst case if all of them are unique elements in the map. So that will be the time complexity and the space complexity. So going back to the sheet, I can say that this one is done as well. I hope you've understood everything. Just in case you have, please hit that like button because it won't cost you anything. But trust me, that is something that motivates me highly to make these kind of videos. And if you're new to our channel, what are you waiting for? Hit that subscribe button. If you haven't followed me on Instagram, you're missing out on a lot of informative content. So please make sure you do check me out on Instagram, Twitter and LinkedIn and everything. And here with this, I'll be wrapping up this video. Let's meet in some other video. Till then, bye-bye. Take care.
Whenever your heart is broken.